What's going on, everyone? This is the Bridge for Math Dr. B coming at you again with a video tutorial on logarithms. In this particular case, we have a specific question. I hope you've had a chance to see the tutorial on properties and facts and rules of logarithms I have. This will totally help you out with this one. So let's check it out. Question is, find the sum of the following terms. So usually, to truly understand logarithms, a professor will test to see how you're doing by giving you a whole bunch of different logarithms, change it up a little bit just to try to trick you, to see if you really understand all the rules and the properties. So the question has log of 10. Notice they don't give you a base on that one. This question has 6 times log of 1,000, no base given. And I want you to notice, if you can pay attention, the notation for logarithms, there's actually a little bit of space between the log and the input 1,000. There's usually a little bit of space. On this particular question, I put it as a lowercase l like the math books typically do. You'll see me switch back and forth from a capital L to a lowercase l. I like putting a capital L so you know it's a logarithm and not a 1. This one is a natural log with a space with an input e to the 4th power. So we need to make sure you remember natural logs, since it's basically a logarithm with a base e, the Euler constant 2.718. This one has plus log base 7 of 7, plus log base 4 of 16. So this question has a whole bunch of different types of bases, different inputs. It's got exponents in different places. It's trying to trick you. Can you handle it? I believe you can, so let's give it a shot. And if you see in the solution, I'm trying to show you lots of different ways to see it. But if you're fast and you know it automatically, just go through it. Log of 10. I hope you have that memorized. That's 1. But we can rewrite this as log base 10 of 10. And one of the facts, if your base and your input are the same, it's always going to equal 1. So the fact is log of base b of input b is equal to 1. So log of 10 is equal to 1. That's one way of looking at it. Plus 6 times log of 1,000. Well, let's rewrite log of 1,000. Log of 1,000 can be written as log 10 of input 10 cubed. Or if you memorized it, it's 3, or use your calculator, it's 3. But I'm going to show you again. Let's use the power property. That exponent now comes down in front, multiplies log 10 of base 10. Oh yeah, you remember log 10 of base 10 is just 1 from the earlier one we just did. So that would be 6 times 3 is 18. So now we got 1 plus 18. Let's look at this next one. Natural log of input e to the 4th. What can you do with the exponent? Excellent. By the power property, you can bring the exponent down. So this 4 comes down in front. So it's 4 times natural log of input e. Well, fact, natural log is also known as log of base e. Well, what happens when you have the same base to an input? It's equal to 1. So it's 4 times 1, and you have 4. Log 7 of 7. Do you see it doesn't matter what the base is as long as it's positive and not equal to 1. But you have base 7, input 7. That's just 1. Do you see how important that understanding is? This one over here I solved it 2 different ways. Log base 4 of 16. You could look at it as, oh, this is logarithmic form. A logarithm is an exponent. The base 4 to what power equals an input of 16? The answer is 2. Well, I changed it from logarithmic form. If you saw one of my other tutorials, I like using puzzle pieces. Blue for base, green for input, sexy red for your output over here. That's logarithm form. Sometimes change it to exponential form to see if it's easier to see. In this case, it becomes really easy to see. It's 4 raised to the y power equals 16. What's y equal to? 2. Or you could use the change of base formula, where log of 16 of base 4 is just log of 16 of any base you choose divided by log of 4 of any base you choose. As long as it's the same base, use base 10. Simple on your calculator. Log of 16 in your calculator, you know it's going to be bigger than 1. It's 1.2. Log of 4 is equal to 0.6. It's equal to 2. We knew that a few different ways. You take all these numbers, you add them up, it's 26. So that's the type of test question you can handle, kind of put together all the properties. I hope that helped you. Continue to look for more applications of exponentials and logs. This is the Bridge for Math, signing out. Take care.